From this part on, we'll be focusing on the thin converging lens. So let's first look at its main features. Okay, so this is the thin converging lens represented by the vertical line with the two-headed arrows. So some of the terms that you need to know will be optical center, middle here of the lens, the principal axis, the focal plane, the focal length, which is represented by a small letter f, as well as the focal points, okay, or principal focus, represented by capital F. So this one is with the lens, and when the light rays come through, you see the optical center, the principal axis, the focal plane, the focal length, small letter f, and the principal focus or focal point with capital F. Same thing for this example here. Let's look at the features of a thin converging lens in details. First, you have the principal axis, which is the horizontal line that passes through the optical center, capital C, of the lens. And this principal axis is perpendicular to the vertical plane of the lens. And your optical center C is the midpoint between the surfaces of the lens on its principal axis. So these are the two surfaces. On the principal axis, you have a midpoint, the optical center. Then the rays that passes through the optical center will not be refracted. Okay, moving on. The focal point F is the point at which all your rays that are parallel to the principal axis converge after refraction by the lens. Remember, they converge at a point. We call this the focal point F. And a lens has two focal points, one on each side of the lens. You have one here, another one this side. If the rays are coming from this side, and they will converge over here. Then the focal plane is the plane that passes through the focal point F, and it is perpendicular to the principal axis. Now the last feature of the thin converging lens, we have focal length represented by small letter f. This is the distance between the optical center, capital C, and the focal point, capital F. Now for every lens, they have their own fixed value of focal length. And this focal length depends on the curvature of the surface. Next, before we move on to learn how to draw ray diagrams for refraction by thin lenses, we need to know how to trace the path of light through a thin converging lens. So there are three definite paths that your light ray can take. Path 1. If the ray is passing through the optical center C, such an incident ray that passes through the optical center C, it will actually pass straight through without any bending. Path 2. The ray parallel to the principal axis. So the ray that is parallel to the principal axis, this incident ray would be refracted or bent to pass through the principal focus or focal point represented by capital F. Path 3. If the ray passes through the focal point F, okay, such an incident ray that passes through the focal point F is refracted parallel to the principal axis after passing through the lens. And if you look closely, you can see that path 2 and path 3 are actually just the reverse of each other. Right, before we move on further, try the examples under Test Yourself 12.2 first. Question 1 on page 12 of your notes, and question 2 on page 13 of your notes. For question 1, please use the labels A, B, C, D, E as labeled here to answer your questions.